So, okay, ladies and gentlemen, let's take a look at what's going on here. I sent, well, I didn't send, but in Canvas, in case you guys didn't notice, I graded your test one, at least the in-class portion, and that was worth 125 points. Your take-home portion is due on Monday. That's another 25 points. So the total will be out of 150, but the take-home portion that you get out today is out of 125. And so what I have also posted in Canvas in the module called Study Guide and Test Solutions is the test solutions. So there was about 50 check marks. There's 50 things that I look for when I grade, and I'm looking for correct things. So there's 50 things that I'm looking for. And as you guys can see, there's all these check marks by what I'm looking for. So I have a summary of solutions there. And then also, what else am I looking for here? At the very end here, I have all the work associated with that summary and the check marks. So I have the work there in detail. So I've posted the solutions online for you guys to take a look and review. I'm also going to do something like this. I'm going to remind people that I have a bunch of resources, not these. This is for the last class. I have resources that might help people. First, let me go home and get to Math 260. I'm sorry, that's not it. Let's go to Math 261. Now, some of you guys may want to review the 261 worksheets and videos. Okay. Now, you might say, what do you mean by that? So I'm going to put a page and send it to you guys in Canvas of some things you might want to review to continue, you know. Things like this. On this sheet, some people may want to review like integration by substitution that you guys see here. I have these reviews, integration by substitution. Now that stuff's not going to go away. So that's why you want to review it. Also, in terms of derivatives, some people may want to review increasing, decreasing functions for derivatives. I have that here too, so I'm going to put that on a page. You might want to review concavity, concave up, concave down. These are all from Calculus 1, by the way. So that might be pretty helpful. So I'm going to put some things there to help you review to continue. Now, in Calculus 2, though, I think we did have resources. If I could go find it. Jesus, it's kind of, come on, Calculus 2. So go to Calculus 2 now. And believe it or not, I did also, here's kind of the Calculus 2 resources as well. I did have for you guys resources here as well, right? Derivatives of inverse trig functions. I think I even sent that to you guys as an announcement. Integration of inverse trig functions. So you do have some resources to help you review so that you guys can proceed, right? So there's Calculus 1, some resources. And we need this. Oh yeah, here's Calculus 1. I'm going to put that there too. It's all going to be there in the chat for you. And then I'm going to even suggest some people may want to review, and I'll put that as well. 125, I do have worksheets and videos here. You might want to review sign analysis, right? So there is some algebra here. And if it's going to help you proceed, I think that's great. So I'm going to put this all in a single page, send it to you in Canvas, all these links. So this is what I'm saying. Here's some sign analysis in particular. And, of course, you have also the video solutions to these. So all of these have video solutions. So let me put that in pause. So those are some things you may want to go back and review because it's to continue. You want to be strong in the fundamentals, strong in the basics. So as you're going to see today, you're going to have more material, more more integration. But those are the resources that I'll provide for you guys on a page to review, because that's what's needed. You have to know how to differentiate, ladies and gentlemen, and that even includes chain rule. Okay? And you have to know how to integrate, and that even includes U substitution. Okay? So all those things you have to know how to do. If you don't, then, you're stuck in the mud. So you can review those things on your own time. Sign analysis as well, do calculus with sign analysis. And in Calculus 1, like I said, there are some resources here. If you have to go back and do that, I'm looking at, derivatives, product rule, quotient rule. There should be chain rule here. Derivative of trig functions. There we go. Chain rule here, so that people can actually review those things as well. So that stuff just doesn't go away, and you'll have them in probably all your exams, and quite honestly. And there, like I said, there's the video for that as well. So, you have tons of resources that I'll refer to. Even things like area and volume, all those nice things are even in a Calculus 1 setting here, right? So if you guys scroll all the way down here even, area between curves, volume, the two volume methods, that's going to come up with us as well. So, you have a bunch of resources to review calculus, because they're all used in Calculus 2. So to let you guys know, I graded your test 1, and you'll get it back today. And, that's that. The test 1 in class. Take home is due on Monday. So anyway, okay, so a bunch of resources there for you guys. Oops, I guess I wasn't on that. I was right here, so sorry about that. Okay, I won't go through all of them again. But we're going to start today with a new integration technique. I abbreviate integration by parts, IBP. Okay, that's really, we're gonna look at the product rule for derivatives, and we're gonna kind of look at how that product rule gives us an approach to integration, how to integrate. So if you remember the product rule, right, you have the product of two functions, f and what? And g. So by product rule, you can pull out the first function and you differentiate the second function, right? And then I can pull out the second function and then differentiate the what? First function. So this is product rule for derivatives here. So there's the f. You guys can see that. And then we have the g here. All right. Okay, so that's by product rule for derivatives here. All right, so we know what's going on there. Okay, so in particular, let's do some shorthand. So here's a shorthand. The derivative of the product, well, we have this as f of x. Now that's g prime plus g of x times my f prime, ladies and gentlemen. Okay? Now, what this implies is something important. This implies that if we integrate the right side, okay, because this is an antiderivative now. If we integrate the right side, well, then that's going to simply be fx gx. You know, you could put that constant, but I'm going to leave it out for now. Yeah, and that's just by definition of what we call the antiderivative, if you guys remember that from Calculus 1, the antiderivative function. But then on that left, I'm going to say this is the integral of two things, fx g prime x dx. The integral of a sum is sum of integrals. Right? And then that equals that right side fx gx here. Okay? So now here's kind of essentially the equation I'm kind of getting at, in all honesty. Okay, so I'm going to do a little bit of algebra. And here's what I'm going to solve for. I'm going to solve for the integral here. I'm going to solve for this right here, this side. Let's solve for what you guys see here. So here's what I'm saying. That the integral of fx g prime x dx, solving for that integral, is fx gx minus the integral of gx f prime x dx. Just solving for that integral here. Okay? So just solving for that, algebraically speaking. So this is, starting with the product rule for derivatives, this is kind of what we end up with. Now, this is a great process and a great procedure. You say, why is that so great? Well, I'm going to pick some colors. I'm not so sure. This is going to kind of mess me up. All right, maybe pick, wow. Here's what I'm going to say. Okay, so we're going to let u be my f of x. I'm not sure. I'm going to have to change some colors, but here's my u function right here. I'm going to let u be f of x, and then I'm also going to let dv be g prime x dx. So this is, yeah, there we go. So what I'm actually saying is that this portion here in gray is actually dv. So here's what we say. The integral of u dv now, and that's on my left side in purple, okay? Where u is f and dv is g prime x dx. So we're changing the variables here, okay? Now, you might say, well, I see f again. Okay, well, what does f represent again? F is what? U. And then you say, but I also have this g function. What in the world is g going to be, right? So g, ladies and gentlemen, go focus on the gray portion here. If dv, right in here, is g prime x dx, I want to say this is dv dx. They're saying is g prime x dx. What they're really saying is v is going to be what? Is g of x. And that color, I guess, is pink now. Okay? So this will be my v. And you say, well, how did you get that? Well, because v is the antiderivative of g prime x. What they're really saying is v is your g here. So all of that comes from, really this gray portion. That's where it comes from. And then now, you know what g is. You say, my g is v right here. So, okay, that's v now. And then you say, but I have f prime x. What is f prime x now? And let me see if I could get a color here. It's available. I don't know. All right, we'll do a lime color. This portion here. Well, you say, where does that come from? Well, I know u is f of x, so du dx is f prime x. that means that du will be f prime x dx. So here is that lime color, meaning we replace this portion here with what? Du. Okay? And I know you look at all this color and you say, what is going on? Well, here's what's going on. The integral of u dv is uv minus the integral of v du. This is what you want to memorize and sing in the shower. This is really what we're looking at. Okay, I derived it for you. And now we're going to have to use it. Okay, so here's the technique. And you want to sing that in the shower? This is integration by what? By parts. It's the integral of u dv equals uv minus the integral of v du. So I remember that phrase. I learned it years ago when I was your age. Integral u dv is uv minus integral v du. You sing that in your shower. Integral u dv is uv minus integral v du. So that's where this formula comes from. And now we want to see how to what? How to use that formula. And this is integration by parts. And so, all right, let's try to stick with something kind of reasonable as a reasonable example here. We'll start simple and easy. You have an integral of x e to the x dx. Probably the simplest example. I don't even know if it's in your book. It might be. Probably the easiest example of integration by parts you guys can see. Okay? Now, you say, what do I really need to do? Well, you're going to need to start this process by letting u be one portion and letting dv be another portion. Okay? Okay, see what I'm saying? So you say, what are you talking about? Well, you're looking at that right here on the left side. This is the product, the integral of u dv. We're changing the variables. Okay, so that's on the left. So I'm going to say to you guys, I'm going to use these colors here. Change the colors on you. I'm going to let my u be what? X, okay? And then you might say, why? I'll show you why I let that be x. What that forces my dv to be is what? E to the x dx. Okay? So already off the bat, I go, oh, this is the integral of u dv. I already know what that's supposed to equal. What is that supposed to equal? That's supposed to equal, ladies and gentlemen, sing the song uv minus integral v what? Du. That's what it's supposed to be. Okay? Because you sang the integration by parts song. All right. Now you say, okay, what do I do next? Well, here's what you guys do next always. Notice if you have u, you already have u. It's right here. We need v. Is that true? So you say, how do I get v? You get v by integrating e to the x dx. Okay? Now, you say, how do I get my du? Well, you get du by differentiating u with respect to x. So in this case, I already know u is what? X. So what I'm saying is this sets your table. So du now dx. What's du dx, ladies and gentlemen? You know the derivative of x? What's that going to be? 1. You can solve for du by multiplying both sides by dx, and now du equals what? So what I'm saying is, you just found, I have to pick another color, I don't know, you just found right here your du. All right, you guys okay with that? And your du here is going to be what? It's simply dx. But what is v going to be? Well, can you integrate e to the x? Yes, you just got through doing that on a test. Here's your v, okay? And that goes here and here. Okay, so we already know. What is u? Well, that's x. What is v? E to the x. It goes in these locations here. So you're using the integration by parts formula. So this integral becomes now, this is equal to what? Right? Remember the song? Integral u dv is uv minus integral v du. So I know what u and v are. This is x e to the x minus the integral e to the x dx. Okay? So take a look. This is that integration by parts formula. Okay, so now you might say, what do I do now? I integrate e to the x. Do you guys know what the integral of e to the x is? What's that going to be? And you could say it's e to the x plus c. Now we have our c. So ladies and gentlemen, here's the deal. You can integrate x e to the x dx, and that's going to be x e to the x really minus e to the x plus c. So now what you guys have is another tool in your belt to actually integrate functions, ladies and gentlemen. Okay, you guys okay with that one? Okay, because that's probably the easiest one you can do in integration by parts. Yeah. Because you save it at the very end. You're going to save that constant at the very end when you integrate.
When do we know we have to do integral by parts, or do we just solve the integral by itself?
Oh, that's a very good question. When do you know? Well, I would say when you look at this section, in all honesty, you're gonna do a lot of practice integration by parts. That's what this section's about. Now, if you said to me, well, what's a big tip-off? Here's the tip-off. First of all, you have a product of two functions. One of the functions breaks down when you differentiate. Now, that's a lot easier said than what? Done. Yeah, I'll say that again. How do you know when to use integration by parts? Well, first of all, you have a product of two functions. One of the functions breaks down when you differentiate. However, you're going to see as you go through a bunch of these examples that that's a lot easier said than done. Sometimes it doesn't break down, and that's a whole other story. So I would say, what's the good thing to do? In this chapter, you have a whole bunch of integration techniques. So you say, well, how do I know just by looking at a function? Well, you have to start working with some of these and integrating some. Then you recognize them, and then that's how it really happens. But it starts with that product of two functions where one breaks down when you differentiate that. So I'm just looking here. This is like 8.1. Yeah. So that's the thing. So you're not going to have, there's not a simple answer other than that. That's the easiest answer to give people. But that's, like I said, a lot easier said than done, because you're going to see a variation of a lot of these things. So you're going to actually have to pull your hair out, kick and scream, and you're going to have to try some of these here. That's how you learn integration. Okay? So just to give you guys another very simple example, and you say, what if they gave me this question here, right? This is very much like the other one. Very easily. Do you guys see a product of two functions? Okay. However, you said, I see a product of two functions. I know, but what do? Here's my u, right? If you let u be x, what do you guys know? Does that break down when you differentiate? What I mean by breaking down, the power reduces? The answer is yes. And so that's going to be my u. Probably, then dv is going to be what? Either 2x, don't forget dx. So this portion is the dv. Okay, so this is how you start the process. Now, if u is x, du dx again is 1, which means du equals what? Dx. So I need this information right here. I need these two pieces. I also need to know what v is. This is dv. So you get v by integrating e to the 2x dx. Now, here's my point. If you don't know u substitution, what's the problem? You're not going to integrate v. You're stuck right there in the mud. Okay, you guys see what I'm saying? So you have to learn u sub. It doesn't work any other way. It doesn't work if you don't know u sub. But you have another problem here. What do I mean by another problem? I'm going to say this. You can't use u sub. Why shouldn't you use u sub? You already have u over here. It's a different u. So you might confuse yourself. So what I'll say is use, what I usually say at this point is use t sub. There's no difference. So you say, what is t sub? You're going to let t be what? T be 2x. dt dx is 2. dx is dt over 2. So then your v now, ladies and gentlemen, is going to be e to the t dt over 2. Pull out the 2. You get 1/2 integral e to the t dt, which is 1/2 e. What was t? Okay, e to the t plus c. T is 2x. So it is a worthwhile investment, and I guess that was green, but you got to invest in u sub, or really what? T sub. Okay? Now, some people, when they look at this integral already, because they go, okay, here's my dv, and then they look at that integral, they already know, because they've done a whole bunch of u sub, they know that this is 1/2 e to the what? 2x plus c. Because they already know what? U sub. Okay? But be careful, because if you say, I want to do u sub, there's already a different u. That's a problem. All right. So integration by parts, what does this equal? uv minus integral what? v du. Okay, so you get used to singing the song in the shower. The integral of u dv is uv minus integral v du. This is integration by parts. So, okay. So you now say, well, what in the world is uv anyway? Well, u is x. You just got v. 1/2 e to the 2x, right? And, oh, yeah, remember we keep the c out, right? So this is uv minus integral of v. We just found v. 1/2 e to the 2x du. And du we know is dx here because we found that here. So u is x and du is dx. Okay, so this now is what we have to integrate. However, let me take that back. This is what you integrate. So this becomes 1/2 x e to the 2x. Pull out the constant 1/2. You have to integrate e to the 2x dx. So this here is your integral. Now remember, they assume you already know how to integrate this. What is that integral of e to the 2x? What's this? It's 1/2 e to the 2x. Yes, there's going to be a c. Okay? But all together, 1/2 x e to the 2x minus what happens with these two constants. What's 1/2 times 1/2? It's 1/4 e. 2x, now I can put that constant again at the very end. So ladies and gentlemen, there you guys go. That's again how you integrate. They assume you could do some u substitution on this. All right, another example. Here's what I'm going to say here. They're going to say integrate x squared sine 2x dx. Okay? Now remember, you got a product again. X squared. And then you got the sine 2x. Okay. There's a product of two functions. Which one breaks down when you differentiate? What do I mean by breaking down? Well, reducing the power. That's what we mean by break down when you differentiate. So what does that mean u has to be here then? What's a good starting point? We're going to let this be u, and this whole thing's going to be my what? dv. You say, okay, u is going to be x squared here. The dv is sine 2x, but don't forget, you need to bring along what? The dx. That's absolute. Because you have to have that equation has to make sense. Meaning, if dv is sine 2x dx, I can find v by integrating what? The sine 2x with respect to that dx. Okay? So now we need du. So you say, well, how do I get that du? Well, differentiate u with respect to x, and you get what? 2x. Solving for du means you have 2x what? dx. So, like I said, you need that information, this information. You know, again, I can use all four colors again. Try to find four colors, orange and pink maybe, and green and brown maybe. I don't know. Okay? So what's the song again? Yeah, this is going to be equal to uv minus integral v what? du. So I didn't get v. I apologize. What's v? Right? We got to integrate sine 2x. Notice, don't you need u sub here to get that v? The answer is yes. U sub will give me 1/2. Oh, derivative of... That's minus what? Cosine of 2x, ladies and gentlemen. So you're going to need to know how to integrate with u sub. So like I said, u sub does not go away. It's never going away. So if you're hoping it'd go, it's not going. So it's a worthwhile investment of time and energy. Is that right? Okay. So let's do U and V. So you say, okay, what's the U and V now? X squared times negative 1/2 cosine 2x minus the integral of, so you're going to put that V in there. You can say, what is V? It's minus 1/2 cosine 2x. And du, you say, what is du? Do you guys know what du is? 2x dx, and I'm out of space. 2x dx. Okay. So notice I'm substituting here. All right. So at this point, you really have to simplify this. You say, oh, is that 1/2 x squared cosine 2x, right? Put your constants there. And then this is plus what? Do you guys know? Let's be careful here. The 2's cancel, don't they? And then minus the minus makes that a plus. And then you put the x before the cosine 2x dx. So, at this point, ladies and gentlemen, you might say, what do I do here? Well, we have to integrate here. Is that right? Okay, so what do you guys do then if you have to integrate? This should look kind of familiar. What do you guys think you have to do to integrate here? You're going to have to use what? Integration by what? Parts again. Why would you use it again? Because you got to break down this what? That x. There's an x there. There's a product again here. Okay, so you're using integration by parts twice. Sometimes that happens. You want to know what the tip-off is? Right in here. If you see x squared, you're going to do it twice. If you see x cubed, 3 times. If you see x to the 4th, 4 times, but they're not going to give you that. Okay, you guys understand what I'm saying? They're not going to give you that. Yes? Always, yes. Because then you can't integrate here to get v. It doesn't, and then you have, if you said, hey, the dx should be gone, right? You go, get rid of that. No, then that makes no sense. You need the dx, because then that means you can actually solve for dx, and it's using the antiderivative formula. So yes, this whole thing, here's a real question. This whole thing must be dv. It must be. All right. So now you say, what do I do? We'll repeat the process. What do you guys want to let u be again? Yep. And that means dv has to be cosine 2x dx. Okay. So make sure you include the dx. So this gives me du equals dx, and now v will be the integral of cosine 2x with respect to the x variable. So you got to know u sub or t sub, and that's going to give me 1/2 sine of what? 2x. You guys see what I'm saying? The expectation is you guys know how to integrate cosine 2x with that u sub technique. So they're thinking already you guys know how to do u sub. They're not going to go back and go, let's start over on u sub, right? So they're going, okay, you know how to do that. So for this purple part, I'll do it in purple. What's the song? uv minus integral v, what? du. So what does that mean? Well, that means x, because that's what u was. V is 1/2 sine 2x, okay, minus, you say minus what? Well, what was v? V is 1/2 sine what? 2x. And don't forget I need a du. And you say, what is my du? Well, that's dx. That's what du is. We know it from here. Okay, there's my du. There's my du, ladies and gentlemen. So now you say, what's left for me to do? Well, what's left for you to do is to integrate, ladies and gentlemen, over here. Now, that is not integration by parts, okay? Because you can actually even fix the rest of that and say, can I write 1/2 x sine 2x minus 1/2 integral sine 2x dx, where again, the idea is that you know how to integrate here. And you're integrating again by u sub or t sub. So what's the integral of sine 2x? Do you guys happen to know? I think that's minus what? Is that minus 1/2 cosine of 2x? Double check. Yeah, derivative of cosine is minus sine. So, okay. So now be very careful. Constant and what? That's a constant. Even though you say, is that the same constant? Well, no. No and yes. Yes and no. Here's what I mean. What's negative 1/2 times negative 1/2? Plus 1/4 cosine 2x. And then you get to add your constant at the end always. But never, 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 never forget what? Geez, I don't know what color anymore. Don't forget what? That was already there to begin with. So I'm going to bring it down because we have to put the complete answer here, ladies and gentlemen. That actually goes right in here, so you guys know, right? So here's your final answer. Jeez, what happened? Negative 1/2 x squared cosine 2x plus 1/2 x sine 2x plus 1/4 cosine 2x plus c. There you guys go. So like I said, they kind of already assume you know the u sub, and you know this is kind of an interesting situation. Okay. All right, here's another classic question. This one's classic as well. All right, you say, why is this classic? Well, it is classic, but what do you guys think here? Is there a product of two functions here? Say no. I only see one function. So, remember the original question is, how do I know this is an integration by parts question? Well, it's in the section integration by parts. All right, you guys, okay, we're gonna use some logic. So it's in the section integration by parts. So I guess we should be able to use integration by parts. Does that make some sense? But if you were to see this before you ever heard of integration by parts, you would not know what to do. Okay, you guys see what I'm saying? So I understand the questions. However, it's an integration by parts question. So we have to find what is u and then what is dv. Is that right? Well, I'm going to call this u. Why do you think I'm going to call this portion u? Because if I call that u, what am I going to do with that u? I'm going to differentiate it. Is that true? I got to find what du dx is. I could not call this u. why can't I call u dx? So in other words, why can't I say, no, u is dx? Have you ever seen anything like this? Can you differentiate that? No, you can't. So then that must mean that this has to be what? What does that have to be? dv, yes. So my dv here is what? dx. Now that makes sense. You say, why does that make sense? Because now that means v is the integral of just dx, which means v equals what? X, ladies and gentlemen. Okay. Now, what's du dx? Isn't that 1 over x? So you got to know the derivative of natural log. Okay, now remember, you're really solving for du. So du is 1 over x, what? Dx. So you might say, I remember singing the song, the integral of what? U dv is uv minus integral v what? du. So this is a very, very, very classic kind of question. All right. So let's put this together. What is u again? It's the natural log of x. So I got the natural log x times my v, which is x, minus the integral of v, which is x, and then du is 1 over x, what? dx. So I switch the order, so I don't think I can multiply my x's together, so you write it as this, and then what happens algebraically speaking? What's x times 1 over x? It's 1. So you're now left with this integral. Does anybody remember from Calculus 1, how do you integrate dx? What's that integral? Isn't that just what? X. Don't forget to add your constant. And now, ladies and gentlemen, you are done. There's your final answer. X times natural log x minus x plus that what? Constant c. So when you see a single function, and if it's in integration by parts, let that be u, and let the dx be, whatever, dv, I guess, yeah. Here's your answer. Classic question. So when I said earlier, essentially you have a product, well, that doesn't apply with this example. And then you might say, well, how would I know what to do? Well, you're looking at the integration by parts formula, and that's helpful. In fact, I remember, this is another classic question that they give. This is a classic question. You have a product of two functions again. But then again, you say, what is u, and then what is what? dv. Now, here's the problem here, right? You typically say u is the function that does what? Breaks down when you differentiate. Is that right? And then dv is the rest. The problem is, if I let u be ex and I differentiate it, I get ex. If I let u be cosine, what's the derivative of cosine? It's minus sine. It doesn't necessarily break down. You guys with me on that? Nevertheless, this is in what homework? Integration by parts. So that implies you should be able to do it by what? Integration by parts. Does that make some sense? Okay. Now, the reason I say this is a classic question, I'll never forget how to do this. You see, Jaime Escalante, he taught this, and he didn't tell us. He left us this question he left at the end of the lecture. And he said, okay, go home and do this integral and be prepared to give the answer at the next lecture. And everybody what? Went home and did this integral, and we didn't have the internet. We didn't have a solution manual. We didn't have a tutoring lab. Okay, let me say that again. No solution manual, no internet, no tutoring lab. You went home and you said, oh, U is okay. Here's my U. Here's my dv. All right, du dx is e to the x. Solve for du, e to the x dx. You just went through the procedure. And then you say, oh, v is the integral of what? Cosine. And then I have to integrate what's the integral of cosine? It's just sine, is that right? So we went through the procedure because we go, okay, this is going to be uv minus integral v, what? Du. And as we use integration by parts, because he said, oh yeah, you can answer it by integration by parts, and we believed them, we now have the integral of sine, and du is ex what? Dx. Don't forget, this is what? This whole thing is du, and you just put it right here. And then you said, oh, okay, what do we have? We have another what? Integration by parts question to do. You go, okay, another integration by parts. So people went with it again. Okay, here's my u, right? And here's the whole thing going to be my what? dv. So people did integration by parts again because we already knew sometimes you have to do it twice. So, okay, this is what we did. And, all right, you said, okay, du dx is going to be e to the x, where du becomes what? E to the x dx. And v is going to be the integral of what? Sine. What's the integral of sine? It's negative cosine, and that's going to be your v, ladies and gentlemen. Okay? So everybody did this, and we go, okay, what does integration by parts give us? uv minus integral v du. So that gives us negative e to the x cosine x minus negative cosine x. Don't forget the du is going to be what again? Du is right up in here. Don't forget the du again. There it is. It's going to be what? E to the x dx. And then, so people looked at this and you said, well, let's simplify this. This is plus what? Integral e to the x cosine x dx. And you're right back right where you what? Started. So integration by parts yet again. IBP here. That's right. That's the original what? Question. And it's negative. I think you're right. It's negative. Isn't there a negative? Should be a negative. Where do we mess up? Let's see, derivative of sine. Okay, we're good here. Okay. Oh, that negative there. Okay, good. We got to be careful here. This is what I'm saying here, or this is what you guys are saying. There's a negative sign out here. Is that true? You okay with that? So don't forget to change that sign and change this sign. So this really is going to be now what? Plus, and this is going to be what? Minus, okay? And you don't have to put the plus, but it's there. So that's this IBP. So altogether, notice this. I'm going to have to write it down. We got e to the x. This is the first one, sine x. plus e to the x cosine x minus that integral again. Right back where we what? Started. Okay? And everybody came back the next day and everybody's like, wow, I'm stuck. I don't know what to do. And people tried to do different U's and different DV's, and then they got again stuck. It's a classic question. Classic. And you go, why did they give me this question here if I'm getting stuck? I'm not getting anywhere. Well, you got to take a closer look. Here's what I mean. Somebody in class said this. Call that I for what? Integral. You okay with that? Call this that's the same thing. Call that I for what? Integral. So the equation you have is I equals e to the x sine x plus e to the x cosine x minus that same I, because it's the same integral. Is that true? You don't even have to call it I. You could leave the integral there. So somebody noticed this, and then you know what they said to do? Add I to both sides. Don't you get 2I equal to EX sine x plus EX cosine x, which means your I is going to be what now if I solve for I? 1/2 EX sine x plus EX cosine x. And then people like to do a little bit of algebra. They pull out the what? E to the x, and they just have sine x plus cosine x. And in fact, you are what? Done. You say, why, ladies and gentlemen, are you done? Why are you done? This is I, isn't it? Isn't that the original integral we started with? We just called I? So what this means, since you call that I, is that the integral e to the x cosine x dx equals what you guys have here. Yeah, you're just pretty much, you're solving for I, you know. So you some people call it I, some people don't. They just leave it as an integral. They just do some algebra. And so somebody in class noticed, yeah, this is what you do. And then everybody's like, oh, wow. But what was the price you had to pay to be able to do it? This is what this comes down to. I'll remember this integral for the rest of my life. I'll be on my deathbed and I'll remember how to integrate this. I'll forget my name, but I won't forget this. Does anybody know why? Why won't I forget it? Because I cried and I kicked and I screamed. I pulled my hair out. I tried doing this integral with different U's and different DV's. I got stuck. I didn't know which way to go. I went through the learning process. I made mistakes, although they weren't mistakes. I went through the learning process. And that's why when I seen how to do it, I earned the right to see the solution. And I'll remember for the rest of my life. Now, here's the issue. Some people are not going to earn it. You say, what are you talking about? They want to be told, how did you know what to do? You guys know what I'm saying? How did you know, Mr. Judge, you did this? And what's my answer? Experience. Experience? What do you mean? The same experience I just told you guys. So you do have to, with some of these integrals, sit there and do what? Pull your hair out, cry, kick, and scream, and try them out. Because if you don't do that, you're not learning it. That's the truth. Nobody's born knowing what U's going to be for these questions. You have to what? Get your hands dirty on it and try you being one thing, you the other. That's how you do it. Because it's very difficult to tell people. They go, wait a minute, we're looking at this section, and what is you always going to be so I don't have to think? You see what I'm saying? Well, how you start, you is always going to be the function you differentiate or break down. But as you guys can see, that's not always the case. Sometimes it just doesn't break down. And sometimes there's not even a product. You guys see what you guys know what I'm saying? What do you have to do? Get all the questions in that section and know they're solvable by integration by parts. And you try the different U's and you recognize, okay, this is similar to the other one. And you recognize what's similar, what's different. But you do got to have the fundamentals. You say, what do you mean the fundamentals? You got to know how to differentiate, number one. And you got to know how to integrate by U sub, number two. Or T sub now. I used to call it T sub as a student because I was so OCD. I didn't want to confuse my letters like U's. Like, oh my God, I don't want to call this U. I already have another U. What do? I thought like a programmer. If you ever wrote a program and you have a couple of different U's to find different ways, you guys know your program's going to crash. It ain't going to work.
Is the answer in blue, or is the answer the integral of that equal to that?
The answer is, let's add our constant. Come on. The answer is the integral equals what's in blue. Yes.
You said that we can sub out the terms for practice. My question to you would be if dx is always going to be a part of dv, if we were to kind of switch around the views here.
You could do that, but your dx will have to be with the other function. Like, here's the question, right? So here's the question, right? What if you said to me this? Can you let this be you? The answer is what? Yes. Try it out. If that's you, then what is dv? Not v. dv. dv will be e to the x what? You always need the what? dx for the dv. Because it won't make sense. The statement doesn't make sense if you don't have that. So you can switch them like that, and that's what people did. Then people said, oh, derivative of u, derivative of cosine is minus sine. V is going to be e to the x. So that's actually part of the learning process. Some people said, oh, I must have had chosen the wrong u and the wrong dv, and they approach it that way. And sure enough, what happens? They get stuck again. But they're not really stuck. They don't realize that they're not stuck. Most people will think they're stuck, but they're not. It took somebody in class, right before class, to show everybody, hey, notice this. This is minus I. And then, oh, yes, that's what it is. See, having solution manuals is really not a bad idea. Okay, let me say this here. But it's a catch-22. If you look at the solution manual too soon, you didn't earn it. It won't matter. You guys know what I'm saying? You have to earn it. And you could just say, I have the solutions for everything, and I'm just going to look at that, what somebody else did. Well, you know what? You didn't think about it. And because you didn't think about it, you never earned it. Because you didn't go through the pain, you never had any gain. The only way a solution manual is actually helpful is if you earn looking at the solution. And I know this from experience. Because when I was a calculus student, there were no solution manuals. And then what did you do? We actually got solution manuals down the street. There was a store that sold them, but they're illegal because publishers have to sell them to you, you know. So I got some down the street, these illegal solution manuals. You go, oh my God, have solution magnitude to Howard Anton's calculus. Oh, okay. But again, if you didn't earn it, it didn't matter. Doesn't matter. You can give people solutions to everything. It will never matter because why? If they're not busy earning it, it doesn't make a difference. You got to do what? Try that out, tinker what U and DV is, and then that's how you make that progress. Okay, sorry about that, you guys. I'm going to pass back your test. I forgot. And I will see you got their homework's where? Where's the homework? This is section 8 point what? 1. Try some of these sections. Integration by what? Parts. And again, let me say this. What if you said to me, Mr. Judge, do I have any more integration by parts? What? Oh, I hate how this is. Where's 262? Do I have any integration by part videos? I do. Where are they? Let me see. There it is. It's called what? Oh, that's the first classic example. Sorry about that. It wasn't even in my notes, but I always start with the easiest one to do. Okay, you guys okay with that? So you have a whole bunch of examples here if you want to see some more.
Now I have to
Oh, look at
integrate
that one.
tangent and
X secant squared x. Oh, that's a good one. You have a whole bunch of examples of integration by parts. That's more than I ever had. You got to what again? Earn it. Okay, we'll see you guys later. Take care. I'll pass back your test.